Hello AP Stat students. Today we're going to learn about writing a least squared regression line equation by hand, not using your calculator, and how to read a printout of linear regression information in order to find your least squared regression line as well. On the AP exam, many times you'll actually get a computer printout of the necessary information so that you can find the least squared regression line equation. So we'll learn how to do that today. If you look at the scatter plot on the screen, you'll see that we are comparing the weight of pumpkins and their seed count. So we've graphed as the x variable the weight of the pumpkins in pounds, and then so we weighed them, and then we cut them open and counted up all the seeds for a few pumpkins, and we put the seed count as the y value. So you can see that there appears to be a possible positive relationship between the two. As the weight of the pumpkin increases, then the seed count would increase, which makes sense, I think, because you can imagine a bigger pumpkin having more seeds in it. Now, below are the summary statistics for each variable in this association. And we could find all of these just taking the raw data from a table. Notice for the pumpkins, we found the average weight of the pumpkins was 10.4 pounds, and the standard deviation of the weight of the pumpkins was just a little over 6 pounds. And for the pumpkin seeds, we found the average number of seeds per pumpkin, which was about 650.88. And we found the standard deviation of seeds in pumpkins was about 193.51. And then we're also given the R value, which shows that there is a positive relationship, but it's not super strong. And you can tell by how much spread you can see in the points around that red line I drew up there. And I'm not sure if that red line is exactly where the regression line will be, but probably a good estimate. So this is where we can use this summary information to find the least squared regression line. So remember, this is our equation, y hat equals bx plus a, where b is the slope and a is the y-intercept. We can find the slope using this equation right here. And you don't have to memorize these equations, they will always be given to you. And on the AP exam, there's a formula sheet, which these are written on too. So to find the slope, notice I just need the r value and the standard deviation of y divided by the standard deviation of x. And all of these are right here. So using those three values, I can find the slope by just making that calculation. Then we're going to use a fact that I'm going to tell you right now, that if you plot the mean of the x's and the mean of the y's as a point, it is always on the regression line. So the great thing about that is, if I know the mean of the x's and the mean of the y's, I automatically know a point that's going to be on the line. So I can plug those values in to the equation for y and x, and plug in my slope, and that would allow me to solve for a, which is the y-intercept. So it's using those 5 numbers that are in the summary here that I can piece together the least squared regression line. Let's do it together on the next slide. So there's the weight of the pumpkins again, the mean and standard deviation, there's the mean and standard deviation of the number of seeds, and there's the R value. So first thing we would do is find the slope. So I need to use this equation, and I've shown it right here with all the numbers plugged in. And the R value from here, the standard deviation of the y is right here, and the standard deviation of the x is right here. So I do that calculation and I end up with a slope of 14.35. Okay, so that's my slope. So for every pound of increased weight in the pumpkin, it looks like you gain about 14 seeds on average. Okay. Next, we need to solve for the y-intercept. And remember, what we're going to do is we're going to plug in b and the mean of the x's and the mean of the y's in for this part of the equation. Okay. And then I'm going to end up solving for a. So you can see here, this is the mean of the y's from above. This is the slope, and this is the mean of the x's. So all I have left is the a in the equation, so I could solve for a by multiplying 14.35 times 10.4 and then subtracting it from 650.88. And I end up with an a of 501.64. So that is our y-intercept. So now I can write my least squared regression line equation as the predicted number of seeds equals the slope times the weight of a pumpkin plus 501.64 the y-intercept. Okay, so now I can make predictions for how many seeds I'm going to get out of the pumpkin by plugging in weights of pumpkins. Okay, and just as a good review, you should be able to interpret the slope and y-intercept. So remember, the slope is 14.35 seeds per pound. For every pound increase in weight, the number of pumpkin seeds increases on average 14.35 seeds. And the y-intercept, the interpretation would be a 0-pound pumpkin would have 501.35 seeds on average. Again, this doesn't make sense in the problem. We've said that before, that oftentimes the y-intercept won't make sense, especially if there isn't any data that's around an x of 0. So that's okay. It'll work for making the predictions we want to make. Remember, we can't predict for any weights that are any weights of pumpkins that are outside of our data. So keep that in mind. Now, the next thing we need to learn how to do is how to read a printout. And this is a printout from a computer. Okay. Notice they give us a graph, so we were given the scatter plot. And this is the cost of flights is the y value, and the x value is the distance flown. So we're trying to predict the cost of a flight by how far it is. So looking at the scatter plot, you can see it looks like there's a positive relationship. They even drew in the line of best fit. And then below, they give us a bunch of information. Okay, this is the printout. Now, a lot of this is extra, okay? This whole section is not used in AP Stats, okay? So you can just ignore that when you see it. But it will be given to you on the printout, so it's good to know what it is. R squared, we need that, okay? So you can picture that as R squared. And we've worked with R, the correlation, so you could find R by taking the square root of R squared. Okay, so that would be how we would find R. So that is on the table. There's an R squared adjusted here. We don't use that. Okay. This next line, the S and the degrees of freedom part, that's going to be later on in the book. That'll be one of the last things we study. So for right now, it's extra. Here's where the meat is. Right here, this part of the table. Okay. The constant is the y-intercept. So from that part of the table where it says coefficient, that is the y-intercept. And you'll notice below that is the x variable, distance. I know it's the x variable because up here on the x-axis it says distance. That is where you're going to find the slope. Okay, and the numbers you want are the numbers under the word coefficient. The rest of this stuff to the right of that will be later on in the book, right at the end, right before the AP exam that we learn about that. So R is not given, but R squared is. Take the square root of R squared to find the correlation. Be careful, because when you take the square root of R squared, your calculator will give you a positive number, but you should double check that the scatter plot's actually showing a positive relationship. Because if it's not, if it was showing a negative relationship, you would need to make the R negative. Because remember, the R tells you direction. Also remember, the slope and the y-intercept are given in the table under coefficient. The constant is the y-intercept, and the number by distribution, which is the x variable on the graph, is the slope. So our least square regression equation would be predicted fare, or cost. Fare is a fancy way to say cost. So the predicted cost of a flight equals 0.078619 times the distance flown plus $177.21.5. Okay, the correlation, if I was looking for R, would be the square root of 0.482 from above, and that's 0.69. And then remember, it would be a positive. R would be positive because the slope is positive. You should be careful to check that the sign of R matches the slope. That's a common way they can try to trick you. Okay. So now I could plug in distances flown, and I could predict the cost of a flight. And we might want to mention like how we could talk interpretation again of the slope. And about the slope is about 0.08. It means that for every mile flown, it adds about 8 cents to the cost of the flight. And a 0-mile flight would cost us $177.21. So that might be accurate for flights, because maybe that's the luggage fee, and that's the food fee, and that's all that kind of stuff, where that's like the initial cost of your ticket before you've even flown any miles yet, and then the miles get added on. So that could be realistic. Here's another example. The following graph is a scatter plot of wins versus home attendance for baseball teams in 2006. So notice as the wins increase, it looks like home attendance increases. I think that makes sense. The better baseball team you have, usually the more people come and see them. This is a shorter version of the table, or a printout. Okay. Notice it gives us r squared. So we could find r by taking the square root of 0.485. And that would be positive because the line is going up from left to right. And then notice it says the constant, which tells us the y-intercept, and the x variable wins tells us the slope. So if I was using this printout to make the equation, I would say that predicted home attendance equals the slope, 538.915, times the number of wins, minus 14,364, which is the y-intercept. If I was going to talk interpretation of this, it looks like for every win, you can expect about 539 more people to come to your games on average. And if you had no wins, you'd have negative 14,364 attendance. That's not realistic. Of course, the reason for that is in baseball, there's never a team that has close to 0 wins for a season, so we don't really know what's happening around the y-intercept. Looks like the minimum number of wins is about 60. So we can't say anything really about what happens with teams that have fewer than 60 wins. Okay, so be sure you can read the printout and know where the y-intercept and the slope come from.